Hi there. Let's take a look at finding the value of the derivative at this value we're given for theta. You can see we definitely have some nested functions going on. So I might say that my outer function is 1/4 times something squared. My middle function would then be sine of something. And my inner function then would be 2 theta. And we'll take the derivative working from the outside. So g prime of theta would be, now the derivative of 1/4 times something squared, we're going to bring the 2 in front, making that a half, times that something. That was sine of 2 theta. Now we'll multiply by the derivative of the middle function. The derivative of sine here is cosine of something. That something was 2 theta. And then we multiply by the derivative of 2 theta, which is 2. Remember, this 2 is not going to be multiplied by the 2 theta. It's actually coming in front to multiply by this 1/2. So that g prime of theta is sine of 2 theta cosine of 2 theta. If you're remembering your double angle identity, we could go one step further here and make that 1/2 sine of 4 theta. But we're going to get a value, so we're looking for when theta is pi. So we'll substitute pi in at this point. We're looking for the sine, 1/2 times the sine of 4 pi. Now think about where 4 pi is located on the unit circle. That's the same location as 0, the same location as 2 pi. So sine there is 0. So we know that g prime of pi is 0. Next, look at our next function. We're told that f of theta is a sine of 2 theta cosine of 2 theta. Now this is an interesting problem, and we're looking for when theta is pi over 4. Because you can make this a lot simpler by using the identity right from the beginning, and I would. I'm not doing any calculus here, I'm just doing identity work to make this 1/2 sine of 4 theta. Now do your chain rule. I see the outer function is 1/2 sine of something, and the inner function is just 4 theta. We'll take the derivative of that. So the derivative of 1/2 sine of something would be 1/2 cosine of that same something. That something being 4 theta. And then the derivative of 4 theta is 4. So we'll multiply the 4 behind times the 1/2, giving me 2 cosine of 4 theta. And now we're looking at that value when theta is pi over 4. So we'll substitute in pi over 4. So we're really looking for 2 cosine of pi. Cosine of pi is -1. And so we know that the derivative of f here at pi over 4 is -2. How are you doing with that chain rule? Takes a little bit of practice to see those inner and outer functions. Let's switch over here and look at the graph. And we're looking at a semicircle. We're told, I'm going to just do a sketch here. We're told that we have the function, the square root of 25 minus x squared, which produces that semicircle in the upper half. Okay, the radius of the semicircle here is 5. We know that because the square root of 25 is 5. So we're being asked here in number 9 to find the function value at 3. That's simply just a substitution here. We're going to substitute in 3 for x. So 3 squared is 9, 25 minus 9 is 16, so I'm looking for the square root of 16, which would be 4. That's my functional value at 3. Then we're asked for the derivative. And I think it's beneficial if we'll go ahead and rewrite the function as a fractional exponent instead of a radical. It's going to be easier with our chain rule. So remember here, we've got our outer function is something to the 1/2 power. We've got our inner function as 25 minus x squared. So let's go with the derivative of the outer function. You've got 1/2 times that something to the negative 1/2. That something being 25 minus x squared times the derivative of the inside function. So the derivative of 25 minus x squared is negative 2x. Clean it up just a little bit. We'll take the negative 2x, we'll multiply by the half to give me a negative x. And then we know this, because of the negative exponent, it's going to come to the denominator so we can make it positive. Let's plug in now 3, since that's where we were asked to find the value of the derivative. We're plugging in 3 for x. We've got 25 minus 3 squared, all to the 1/2 in the denominator. So that gives me negative 3 on the top. 25 minus 9 would give me 16, and 16 to the 1/2 power is 4. That gives me then the derivative at 3. Now be prepared on number 10. We're going to use this information to write the equation of the tangent line. So we need a point. So our point was 3, and we found the y value to be 4. The slope of the tangent line was our derivative. That's our negative 3/4. So you can write your equation of your tangent line very easily. You've already done all of the work for it. You just need to package it correctly for number 10. Let's look at number 11, very similar approach. Number 11 asks us for the normal line. So remember, with a normal line, you need the point. We've got that. And you need the slope. Now the slope of the normal line is going to be the negative reciprocal of the tangent line. So the tangent line had a negative slope. Normal slope is going to be positive. We're going to take the reciprocal then, 4/3. And then we can write our equation for the slope of the normal line. I'm sorry, for the equation of the normal line. Okay, one more problem in this group here, and that's number 12. We're asked for what values of x does the graph have a horizontal tangent. So when you see horizontal tangent, I want you to think derivative equals 0. We're looking for where the derivative equals 0. So for us, we're going to find the derivative of h of x, and we're going to set it equal to 0. Looks like a good product rule for me. I'm going to rewrite it as a fraction exponent. Watch my chain rule with that fraction exponent as well. So product rule is the first times the derivative of the second. So I've got 1/2 to the negative 1/2, and then the derivative of the inside. Derivative of 2x plus 1 is 2. Plus the second function times the derivative of the first, which would just be x. Let's clean it up a little bit so it becomes clear to us. So the 2 is coming in front to multiply with these halves. So I'm still going to have a 1/2. I've got an x squared on top. And then this guy is coming to the denominator because of the negative exponent. And then I've got x times 2x plus 1 to the 1/2 power. All right, now remember, we want derivative equal to 0. So we're going to set this equal to 0. That looks very ugly, but we're going to make it a lot simpler because we're going to multiply by this denominator to get rid of the fractions. Because easily, if I multiply by this denominator times 0, I still get 0. If I multiply this fraction by this denominator, I get x squared. If I multiply this term by this denominator, I get 2x. And then look, I've got 2x plus 1 to the 1/2 times 2x plus 1 to the 1/2. That's just 2x plus 1. Look at how much nicer that looks than it did before. I'm going to just distribute here. I will collect like terms, a little bit of algebra going on here. It looks like I'm going to factor out an x. And it looks like I'm going to get that x is 0 and x is negative 2/5. Okay, now look back at your function. Remember, our function was h of x equals 1/2 x squared times the square root of 2x plus 1. Do you have any problem with these values? Can x be 0? Yes. Yes. Can x be negative 2/5? Yes, it'll be squared. That'll give me negative 4/5. I'm good. So both of my answers here will produce, both of my answers here will produce horizontal tangents. I hope that helps with this homework assignment. If you have questions, feel free to put them in the comments below. I'll be glad to address them. Bye now.